Today we'll just recap those things we covered yesterday in medium access control, and then we'll go to Ethernet. And specifically we need to mention about this CSMA CD, carrier sense multiple access collision detect. CSMA CA we'll discuss when we discuss wireless LANs. Okay, so we are dealing with shared channel access, and shared channel access is what do you say, has numerous problems. So you could solve it in different ways, either by say some channels, some shared media is randomly accessed. So that is what our problem comes. So the information the frames can come at any time. The control access, you issue tokens. Usually there is some token, or there is a controller which polls the each of these nodes, and then there will be communication taking place. And channelization, that is multiple access protocols in cellular networks, frequency division or time division or code division multiple access protocols. So that protocols will I think I have just left a PPT on that. Multiplexing methods, multiplexing techniques, you refer those things. Telephonയുടെ കാര്യങ്ങളെല്ലാം അതിനകത്ത് ഡിസ്കസ് ചെയ്തിട്ടുണ്ട്. ഹൈറാർക്കി T1 E1 ഹൈറാർക്കിയെല്ലാം അതിനകത്ത് ഡിസ്കസ് ചെയ്തിട്ടുണ്ട്. So random access methods say all the users have, all the nodes have equal right to access the channel. So and they can access the channel at any time, but the problem that comes is that there will be a collision. There is a chance for collision because there will be contention for the shared medium, for the channel. So because of collision, that means two or more nodes will try to communicate at the same time, send frames. We'll talk about frames, that would be better rather than packets. So this media access control is a function of the data link layer. It's actually a sub layer, logic link, say logic link control and logical link control and medium access control. So media access control, we will see the elaborations later. So for the present, assume we say that the collisions can result in say even one bit of these two frames get overlap, means you can corrupt, or maybe the packet is damaged. Either of these frames can get damaged. Different random access methods are there. One is the most simplest one, that is called as Aloha. Aloha is one of the first random access methods, and we saw that the stations can send at any time in the pure Aloha, and the frames could overlap. There was possibility for collision and loss of packets. It's an inefficient technique as well. So this is not a very good way to do that. Aloha was specifically tuned for satellite links, and then slaughter Aloha, where you give time slots. So actually this is an extended version of this things applies in modern day networks, you can say, in Ethernet, the earlier forms of Ethernet slots. So you could say that there is each of this could what do you say, transmit only at the beginning of a time slot. So station when transmits, if it has more data to transmit, it has to wait for the next slot to begin, only then it could transmit. Here, so the stations will not, or the nodes will not transmit at random. They would be able to transmit only at the beginning of an interval. So they have to wait. That is one thing. They have to see whether the time slot began or not, wait for the beginning of the next time slot. That's why I said wait is a concept that comes in CSMA CD. So again you saw that this has problems, and you are coming to this can reduce the number of collisions, but still it is not a very good technique. So there is something called as carrier sense multiple access. So carrier sense multiple access means you will monitor the channel and check whether any transmission is taking place. You will check whether the channel is idle. So and only then it transmits. Now the problem is that it depends on the length of the network and how far it is a particular node is situated from the node which is transmitting. Say for instance, in this case node B, and we'll take the case of node B and node C. Okay, so node B and node C. So node B begins transmission at T1 and it sends the frame, it propagates over the network, it goes to all the nodes. So this is shown inclined to indicate it is in space, in time. So time propagation delay, it's to show this is shown slanted, the blue line is shown slanted to indicate that it is propagation delay is there. So at the same time, then say at time T2, just what do you say, after T1, T2 greater than T1, C checks the channel and sees that. So as of now, C doesn't see this channel as busy. It sees it as idle and it sends its frame. So at this point, at this particular point, there is overlap, there is a collision. Now that is what the problem is. So the collisions can still occur. So and you could say the time, you can say that A has to wait until say any node has to wait until this propagation time, only then it can transmit. That is the vulnerable time. Vulnerable time is only after the vulnerable time is elapsed, any node on this network can transmit. A can still transmit, but it will check the channel, it will say it is idle, it is busy, it is some energy is there on the channel, signal energy is there on the channel. So that is the vulnerable time in CSMA. So CSMA was not a very good way to do that. Then CSMA involved some things called as persistent methods. Persistent methods is a way to do say some strategy to do to take when adopt in the case where the channel is busy. So in one persistent method, this 1 comes from the probability P equals 1, probability 1. Okay, and P persistent, the probability P, that is it transmits the frame with the probability P. That is what P is chosen randomly. That is what. So in one persistent approach, what is done is that you will check whether the channel is busy or not, channel is idle. So then it will transmit the frame with the probability 1. That is, it is so whatever happened, let it go like that. So I am sure that it will get the channel. I am sure that the channel is idle and I'll transmit. That is the assumption, and the frame goes. Anything can happen to the frame. It could get lost. There is high probability for collisions. So because all nodes will make the same assumption that the channel is idle and it will just transmit. Okay, so that is, it's a transmission with the probability 1. That is 1. The non-persistent approach is that the station, each of these nodes will check whether the station is channel is idle or not, and if it is idle, it will transmit, else it will wait for a random duration and then again make a check and only transmit only if the channel is idle. So this is a non-persistent approach. Then the problem with non-persistent approach is that your network efficiency is reduced. Compare in the first case there is high probability for collision, but here the probability of collisions is reduced, but still the network efficiency, overall throughput of the network is reduced. Overall throughput of the network is reduced. So this we'll continue. So that is the network efficiency is reduced. Then compared to this, there is a P persistent approach. P persistent approach is that it will you won't assume that there is you won't transmit the frame with the probability 1. You will take into consideration some other things. You will choose a random probability to transmit the frame, and you will wait for a random duration. That is so this is reducing the network the chance of collision, as well as improves the network efficiency. So it will check the channel whether it is idle. So here we see this flow diagram. It will check whether the channel is idle or not. So if it is idle, you will generate a random number. Random number is so that is P. It will generate a random number between 0 and 1. So it will transmit a frame with a probability P less than or equal to P, and it will wait. It will make a transmission, and it will then wait for the beginning of the next time slot for the remaining probability, remaining time. That is Q equals 1 minus P. 1 minus. So the P is the probability with which it sends a frame, and 1 minus P is the probability for which it waits for the next time slot. So there is a time slot concept there, just like we mentioned in slotted aloha. You have the time slot which is greater than or equal to the maximum propagation time. So it depends on the length of the network. So these concepts are all outdated now, because CSMA-CD is outdated. We are learning it for historical reasons. So when we see later that we have something called a switched Ethernet, and there is very less probability of collisions. The collision domains are separated. So we are learning it for historical reasons. That's one thing we can say. So if it is it will wait for this duration for the beginning of the next slot, and then check the line. It will just wait for the slot, and then it will check the line. And if it finds it to be busy, then it will withdraw from communication. Else it will go to step 1. It will again transmit the next frame, assuming that there is data. So this is a P persistent method. So there is a concept of sending the frame at random and choosing a random probability, and then waiting for the remaining time, and wait for the next time slot, and then checking. So that in that manner you will be able to separate different sources. So time for the next frame, each of these will choose at random. Say one node will choose the time to transmit the next frame after 5 seconds. The other one might choose at 3 seconds. Other one might choose at 10 seconds. So naturally the 3-second guy will check first whether the channel is idle. Someone will get at random. So for instance, if the transmission is taking place by some other node, so each of these will be able to check and find out. So, and whoever gets a chance will be able to transmit. So that will improve the network efficiency, and also so P persistent method seems to be a good method. So but the problem with the Carry-Sense multiplexes, the simple Carry-Sense multiplexes technique, is that it does not specify what to do in case of a collision. So it will just monitor the media, and it will check whether it is idle or not, and it will withdraw from communication, withdraw from transmitting the frame. That's the only thing. And the earlier days of Ethernet, which we'll see later on, they use CSMA-CD. CSMA-CD was the protocol which is used to resolve this contention. CSMA-CD with one persistent approach. So that was a very simple fix to solve this contention. But as the network speed increased, and the data rates increased, so your requirement became more. So this is then we come to you have Carry-Sense multiplexes with collision detect. So that is so this is where the collision occurs. You say that the first bit, so it will transmit the the CSMA CD involves steps like this. Say for instance, we will consider these two nodes, A and C. So what it does is that it's a half duplex line, you can say like that. So so it is sending its first bit and checking whether there is some transmission, on this channel. If it is say it is sending its first bit, and it will observe. So how will it know the collision is that when a collision event has occurred, the station which is nearer to the point of collision, in this case C. So here I have shown the time t1, A is starting the transmission, and C is beginning a transmission at time t2, which is greater than t1. Now C is understanding that there is a collision taking place at time t3. Now once C comes to know that there is a collision, it will send out a jamming signal. It's a particular sequence through to the entire network. It will broadcast, you can say like that. It will send a jamming signal. So jamming signal, so when we take up Ethernet, we see that there is a CRC field there, cyclic redundancy code field there. So CRC field, it will be specifically formatted in such a way that all the nodes will have to discard it. They will get error with this jamming sequence. There will be an extra bits in this format, in this frame. So because of that, all the stations will come to know that there is because of the jamming signal which is sent out by C, which is closer to the point of collision. All the stations will back off, and they will wait for a random duration before trying for the next attempt to send frame on the network. So this is how CSMA CD works. So they'll monitor whether there is idle. Then I'll outline the steps in a small manner. So that is, you will say you will carrier sense, and it will listen. So here this is a common channel. This is, I just summarize the things down the line. So it will monitor, say the maximum 1500 bytes are sent at a time. Then it will check whether the channel is active or it is idle. Then you have to then once you transmit the frame, it will listen the channel, and if collisions occurs as a result of simultaneous transmissions by two or more nodes, then it will stop sending and it will send a jamming signal. The jamming signal is sent by whoever is closer, whoever first identifies that there is whichever node which involved in communication that identifies that there is a collision, and that jamming signal is a 32-bit signal. So it will back off and then retransmit. Then there are specific back off algorithms are there, specific back off approaches are there for CSMA CD. So this is a 32-bit jamming signal, that is what informing the nodes that all the nodes that a collision has taken place. So this is summarized in this flow chart. This is the number of attempts. K is indicating the number of attempts. So a station has some data to send. It is getting this from the network layer, and it is framed, and it is one of the persistent strategies, either one persistent. Say if we take the case of traditional Ethernet, one persistent technique is used, or P persistent, whatever approach is there, you will apply one of these persistent techniques. So it will monitor the channel and send. We will say one persistent, and if it is able to transmit, done, then it will monitor. Once transmission takes place, what happens? It will monitor the channel. It will monitor the channel to check whether there is the transmission has been done or any collision has taken place. If collision is detected, so collision is detected means you will send out a jamming signal, and you will have to go for the next attempt after a random wait, right? You will have to go for a next attempt after a random wait. Hope this is clear. So you'll say increment k by 1 point, so it is 0, now it becomes 1. Then you have given the maximum number of attempts as 15, so 0 to 14. So that is it will check, so it's not the maximum attempt, it is only 1. Then you will generate a random number, and you will back off for a random duration, back off from transmitting, retransmission after retransmit the frame, and after a random wait. So this is the approach in carrier sense multiple access with collision detect. So this is a protocol that is used in your earlier Ethernets, and now it has been superseded by this. Say until 2008 there was this particular thing. For historical reasons, CSMA CD was there in the IEEE standards. Now they have changed the name altogether of that document. They have changed it 802.3, that is the main document. This is 2012 is the revision. So that is, the name is IEEE standard for Ethernet. So gigabit Ethernet, all those things, they come under this standard. So this is a half duplex case, the collision said carrier sense multiple access with collision detect. You have a full duplex connections and switches. So did I mention somewhere the difference between a hub, switch and a router? Hub is a very passive device which allows you to connect yes, Arundu Paranu, someone said something? Hub എന്താണ്? ഹബ്ബ് ഒരു ഇത് എക്സ്പാൻഡ് ചെയ്യുന്ന ഒരു ഡിവൈസ് ആണെന്ന് വിചാരിക്കാം. യു ക്യാൻ കണക്ട് വേരിയസ് devices. Say for instance, in your home you have one internet connection and you want to share it with 5 computers. You can just connect this what do you say, the LAN port to this hub and take connections, LAN connections from this. I am talking of a wired connection. So from this hub you can split up your, say if I have a 4-port hub, so I can expand it to 4 connections. That is what. Then hubs are an obsolete device. Switches, so hubs do not have any intelligence basically. It's a physical layer device. Then your switch has some degree of intelligence. Switch, I'll say it will get an idea of the MAC addresses of the devices connected. So if it gets a frame, it will just forward it to, so switch has a table, you can say something like device A and its MAC address is this, physical address is device B, this is the MAC address. So it knows what all devices are connected to this. So it when it gets a frame, it knows the destination address, it will just forward it to only that device, unlike the hub which will forward it to all devices on the network, and whichever devices doesn't want that thing will discard. That is the hub case. Whereas in your switch case, switch has intelligence, it will forward only to that particular device. So if you have a 4-port switch and your data is intended for device connected to switch the port 3, it will be forwarded only to the port 3. It won't be forwarded to the other 2 ports, other 3 ports. Okay. Then router. So router, what is the router? Router is something which is outside the network. That is what you can say in a broader context. So when your traffic is intended outside the network. Now I'll come to a genuine doubt after this. What our home routers, that is what. Say routers on the other hand, they are able to check the IP as well. You can say that you can say here across, allow you to connect across networks, to interconnect between 2 networks. So you say the traffic is, you are sending for instance, this computer is now connected to the internet. So I'm not sending any data from my computer to my mobile phone or any other device here. So it knows, the router knows it has to be routed to this Google Classroom, has to be routed through some mechanism to other IPs which are connected to this meet. So router knows it is for an external thing. So router has routing mechanisms. It has a routing algorithm, and routing in your TCP IP is done using your internet protocol. So that's the beauty of TCP IP, because TCP IP specification doesn't bother about what happens in the lower layer, the data link and the physical layer. It's not a botheration. IP is a global thing to carry this thing over any media, whether it be fiber, LAN, coaxial cable, satellite link, whatever. It is not a problem. IP is a global address like that. So when we come to the next module, the ideas will be clear. And so router, what about a home router? Someone can tell something. We have home router, alle D-Link inde adindeka home router undu chellarude veettilengilum Wi-Fi idundu. Now say in our homes we have a black box like thing, alle Digilink, what not Digilink, yeah, D-Link. So D-Link inde oru pettiyokke undav, something like this. Say I'll stop the presentation here. Something so D-Link router. So okay, you are able to see this thing, what I am presenting? Yes, Amazon, you have something like that in your homes. This is also a router. Say it's not a modem. Router, not a modem. So what is the difference between a modem and a router? See, I'll try to clarify this, because we need to clear this notion of these things before we proceed to the next module. Say your computer is a digital device, okay, and your rest of the internet is say your telephone line, whatever, your analog signaling is happening. You can't transmit, strictly speaking, you cannot transmit a digital signal 0 and 1 through a telephone line. You have to modulate, some modulation, amplitude shift keying, whatever, QPSK, quadrature phase shift keying, അങ്ങനെയുള്ള modulation techniques ഒക്കെ ഉണ്ട്, modulation ചെയ്യാൻ. അപ്പോൾ so modulation is a role of your modem. That is, it will take all these analog signals which are coming from a computer, convert it to digital signals which are coming from a computer, convert it to a modulated form and transmit, as well as do the other way also. Whatever signal is coming from through the network, through your telephone line, whatever, and then convert it to a digital signal and give it to your PC. So modem is doing that task. So you have different types of modems, something which is called as a cable modem, Ethernet, those who are taking Ethernet connections. Ethernet modem is I think I mentioned this thing, Ethernet cable modem. Yeah, this is the Ethernet cable modem, Cisco da oru modem undu avaru kondu vechittu povunnaanu. Some people have that, right? Is it? You can see that thing. This is DOCSIS 3, Cisco 2100 കാണാവോ? So Cisco 2100 എന്ന് പറഞ്ഞൊരു മോഡ്, ഇതാണ് സാധാരണ ഒരെണ്ണം കൊണ്ടുവന്ന് വെച്ചിട്ട് പോകണം. Cisco 2100, this is the usual one they put. Now what about a router? So modem is required. You have cable modem, then you have DSL modem, digital subscriber line modem. ഇവിടെ എഴുതിയിട്ടുണ്ട് ADSL2. അത് you will plug into your phone line. You will plug into your phone line. So digital subscriber line. So ADSL technology or BSNL, all those things run like that. അല്ലേ? ADSL modem ആണ് ഉപയോഗിക്കുന്നത്. Really? Anyone who has a BSNL a DSL line? Say you, yeah. So you have a DSL modem there. And again you have fiber. Now you have something called as PON. What do you say? You say it as IPON. Yeah, IPON, JIPON. Yeah. So this is images. I'll say IPON modem. Yeah, JIPON, IPON. This is in Amazon again. Yeah, this is a JIPON, IPON modem. I don't know whether they are just showing this port. So it says 1 IPON. That is, this is over. It's an optical modem. You can plug in your optical connector, OFC. Port, the last port, the blue port here. You can have 4 LAN ports, all those things. Say my modem is a Netlink IPON. Yeah, Netlink IPON. So Netlink IPON, I'm more comfortable with that thing. So this is your modem which is uses. So this is a all-in-one device, you could say like that. It is doing a lot of tasks. It is doing this routing business also. Most of these devices which you get at your home, whether it is a D-Link modem, D-Link router, whatever you say, D-Link router, this is say this is having a built-in switch. So it is able to send your data to different devices in your home. Your internet connection is plugged in through your LAN port there, and then it is able to say send the data over to your phone. So your phone, your computer, other TV, whatever devices, that is possible. So that is your routing functions. You have built-in switch there. Switch is also added to this. So then that makes it clear. Your optical modem is a JIPON, IPON. These are technologies which used to convey your data through your fiber optic cables. So you have BSNL fiber to home, then your Kerala Vision, Asianet, all those people have fiber. So you are talking of fiber based technology. Nowadays we used to have something like dial-up modem. Maybe dial-up modem is something which you used to plug in PCI dial-up modem. So this is something which you used to plug in into our PCI card. So a PCI slot. It used to produce a very interesting sound as well. So that is yeah, you had to plug in your telephone jack here. But in daily old computer, it used to make dial-up modem sound. You have heard that sound? Yeah, they know. The Google knows what you are asking for. If you can hear. അടുത്ത ക്ലാസ് എന്താണല്ലോ? 12:40 അല്ലേ? We'll just hear this and just, yeah, we'll just, this was our days. So time and again the connection used to break off also. That was the earlier days of our time, 97 and all. we used to have internet like this. Every time you had this only BSNL those days. So now we are talking of fiber networks, wireless dongles, all those things. So so we'll wind up today's session. We will join back for Ethernet the next day. I thought yesterday there was very low attendance, so that's why I took the second half session again, medium access control. I'll upload this class in the thing in the YouTube. Just those who are still absent can make use of this. Okay.